I wanna be your conic. Oh hush. I'm not singing Boogie Wonderland on request of Brandon. Next, we're on the second column in hyperbolas. We're looking at this one. It's y squared minus a squared, or y squared over, let me try again. Y squared over a squared minus x squared over b squared equals 1. Our center is at 0, 0. The y is in front here, which means it's not the negative one, so it's going to be my vertical is going to be my transverse. Correct. And so if this is my x-axis, this is my y-axis, this hyperbola is going to have branches opening up and down. And just to kind of show you how that goes, let's just say we have a distance here of A and a distance here of B. Okay. Oh, and it doesn't matter if A is bigger than B or not. It doesn't matter which one's bigger.
Oh yeah, good point.
It doesn't matter which one's bigger.
Whichever one's first is the way.
The one, it deals with the sign. Whichever one is with the positive term is the transverse axis. The other one's the conjugate axis. So this distance will be B. And the reason I'm just doing it this way is I'm going to make like a little rectangle to kind of get you guys learning the way you want to do it. So again, this distance would be A from here to here, and this would be from B from here to here. And then I can just draw in my asymptotes, which again would be y equals, but instead of b over a, it's going to be plus or minus a over b this time for my asymptotes. Good to go on that? Now I have not yet drawn in the curve, and the reason I wanted to show you this is because this center right here, A is the distance to the vertex, so my hyperbola is actually going to start right on the edge of this rectangle. And the way it's going to go is it's going to go just inside these asymptotes, approaching it but never actually touching it. Good on that one? And then I've got my branch down here again, and it's going to go out and out. Whenever you draw a hyperbola, you should see this little rectangle box in do it in dashes because you don't actually see it on the graph. Neither do you see the asymptotes. You want to put it kind of all in little dotted lines, but it's going to help you graph it tremendously. Okay?
Okay.
Let me ask you a question. Is this a function?
No.
No, this is not a function. Why is it not a function?
Because
There's more than one output for each input.
Okay. Okay. Remember when we had the ellipses? Is that a function?
Nope.
No. Okay. So what that means is when you're graphing these on your calculator, we can't just put in one equation to do it. We'd have to do it in two parts.
Well, another way you can answer that it's not a function is you can't draw a straight line through any part and it not cross, right?
More than one spot.
Yes.
Correct. Like on this ellipse or circle or whatever we have, we could draw a line out here. It doesn't hit anything. We could draw a line tangent. It hits one. Those are all fine. But as soon as we do something here and it crosses in two, it's not a function.
Okay.
So these aren't functions. So what that means is in order to graph a lot of these, you have to do it in two parts. Like you'd graph the top half and then the bottom half. You'd separate them up into functions to graph them on your calculator. That was just an additional question. Doesn't really have anything to do with this, but we can kill that out.